In this video, we're going to look at converting different angles and trig graphs. So the first one we have 75 degrees to radians. Now you can just go times pi over 180 degrees, and this will give you 1.309 rads. Or you could leave it in fraction form as 5 pi over 12. Now you can also use your calculator by using second function, and then above the decimal place you will see a DRG with an arrow. You can convert between degrees, radians, and gradients just by going second function decimal as many times as you need. But you do have to be careful what mode you start in. For this example, you would want to start in degrees, then hit second function decimal once to get radians. For the next example, you can times it by 180 degrees over pi to give 120 degrees, or you can use your calculator again, but you will have to start in radians, type in your 2 pi over 3, and then hit second function decimal in order to get degrees. Because you go from radians, which is a 2 pi over 3, second function decimal the first time gives you gradients, and then second function decimal the second time will give you the degrees. And here's another example, 212.5 degrees. If we convert this, we get 3.709 rad. And then this example here, 1.655 rad is about 94.82 degrees. Here's a couple of more examples. Now we're getting into what we call degrees, minutes, and seconds. You see this especially with navigation or anywhere else where you want to get smaller angles than just a degree. There's 60 seconds to a minute, 60 minutes to a degree, so very similar to time. On your calculator, you do have a DMS button. And if you hit second function DMS, you can convert between DMS and degrees. So if you type in 165 DMS, 19 DMS, 20 DMS, you can enter this question and then hit second function DMS, and it will tell you 165.3 and then 2 repeated. Often when I'm asking you to convert these, I will also state round to 4 decimal places. Now the second example, we're starting with degrees and we want degrees, minutes, seconds. So we just hit 104.83 in our calculator and then hit second function DMS, and we get 104 degrees, 49 minutes, and 48 seconds. Now this third example, we're starting in radians and want to go to degrees, minutes, and seconds. Well, same idea, but we're first going to have to convert the radians to degrees. We can just use the DRG, and this is about 247.0594013 degrees. I'm keeping all the decimals. You can just keep the number in your calculator. Once you've converted, then hit second function DMS, and then DMS, we get 247 degrees, 3 minutes, and 34 seconds. I usually round to the nearest second. If you want to put a decimal place, you can, but nearest second is more accurate enough for us. All right, let's look at some graphing. This first example, we have this 4 out front, which is our amplitude, which will be 4. So it goes up to 4 and down to -4 with our waves. The 2 affects our period. So period is 2 pi divided by 2. It's always going to be 2 pi divided by whatever this number is. Okay, so 2 pi is a full cycle or a full circle, and then you divide by the v value. So in this case, b was 2. So this is just equal to pi, which means it's going to do 1 cycle by pi. So if it starts at 0, it's going to finish by pi. We know it's going to go up to 4 and down to -4. Now 1 cycle, we'll see it going up to 4, down to the x-axis, down to -4, and then back up. So we end up with a wave that looks like this. Now this is just 1 cycle. These will continue on until infinity or forever in both directions, just repeating that same wave. Here's an example of cosine. Now the 3, our A, is our amplitude, and this time our B value is 4. So our period is 2 pi divided by 4, or pi over 2. So if it starts at 0, it's going to finish one full cycle by the time it reaches pi over 2, or 0.5 pi. Now it's cosine, so instead of starting at the origin, it's going to start up at the amplitude, and it's going to finish at the amplitude. Halfway, it's going to be down at -3, and then at 1/4 and 3/4 is where it crosses the x-axis. But we still have a wave function, and it's just going to repeat this in both directions. Forever. So it's going to keep going forever. Now, you'll notice, if we look at this function, if we had started here and went along, that is just a sine curve. The only difference between a sine curve and a cos curve is that sine starts at the origin, and then cos starts at the amplitude. Now, in this example, we have an amplitude of 2. Our period is now going to be 2 pi divided by 1/2, or 4 pi. So this time it will take all the way to 4 pi to complete a cycle. So it will complete half a cycle by 2 pi. Our amplitude was 2, so halfway is here. I'm just going to do the same in this direction. So it stretches it out, makes it really long. Now here we have y equals tan x. Now tan x doesn't get used as often in applications because it's not a continuous curve. Sine and cosine is the more common ones used. But we can still graph tan x. One thing with tan x is if we look at the domain, x cannot equal pi over 2 or 90 degrees, and it cannot equal multiple that plus or minus factors of pi, where n is just an integer. So basically what that means is that at pi over 2, 1.5 pi, 2.5 pi, negative pi over 2, negative 1.5 pi, and so on, we have what we call asymptotes. So the graph will go through 0 and look something like this, and just repeat that. So it's still a cyclic function or periodic function, but it's not a continuous function because it has all these breaks in the graph. In this example, we start introducing what we call phase shift or a horizontal shift. Now the 5 still affects our amplitude. The 2 still affects our period. Our period will be 2 pi divided by 2, which is pi. But what I like to do is I factor out the 2, give me x minus pi over 2, so that this is our phase shift. So our phase shift is pi over 2. So it's actually positive pi over 2, or to the right pi over 2. It's always going to be opposite to the sign when it's in brackets. So if we were to graph this, let's use green. So if we were to graph this without the phase shift, we would have up to 5, down to -5, and finish by pi. Here. So this would be This would be y equals 5 sine 2x without the phase shift. By adding the phase shift, each point has been shifted over. So we're shifting that over. So we start here instead of at the origin, but it's still going to be the same curve. We've just changed where it starts. So this will be your 5 sine 2x minus pi. And then it repeats that indefinitely in both directions. And so on. Here's another example with a phase shift. Let's just start off by factoring out that 4. So we have 4 cos, factor out the 4, giving us x plus pi over 8. So this is our amplitude, a equals 4. This will affect our period, which is 2 pi divided by 4, or pi over 2. And then this is our phase shift, which will be negative pi over 8. Opposite to the sign, remember? So now we're going to go up to 4, down to negative 4. And let's graph it without the phase shift first. So it's cosine, so it starts at the amplitude. Pi over 2 is the period. Halfway, it'll be at the lowest most. And it's going to cross here and here. So this is what it looks like without the phase shift. So y equals 4 cos 4x. But now we're going to shift it pi over 8 to the left. Now, if this is negative pi over 2, this is negative pi over 4, this would be negative pi over 8. So each one's only being shifted that tiny little bit. So let's just shift each point and then connect them. And then of course, this is just going to continue in both directions to infinity. So here's an example where I give you the graph and I want you to find the equation. Now it's easy to start with the amplitude is just going to be 4. To look at the period, if we start at 0, it's going to do 1 full cycle by pi over 2. So our period is pi over 2, but we know period pi over 2 equals 2 pi over b. So we can figure out that b, in this case, will be 4. From there, we don't have to have a phase shift here. So the answer to this one is just y equals 4 sine 4x. Now, that is one answer if you wanted to do a cosine. Because it doesn't, a sine curve and a cosine curve are the same, but with cosine, you would have to have a phase shift. So it would be y equals 4 cosine 4, and then x minus pi over 8. Again, it's an or. You don't have to give both. The sine's easier because you have no phase shift. But in this case, a cosine will give you the same curve. Here's another example. This time, our amplitude is going to be 5. Our period, if we were to say start here and go to here, that's 1 full cycle. As you can see, that's the length of pi. So if our period is pi, we know 2 pi over b equals pi, so b equals 2. Now, we do have a phase shift here. If you're going to start with sine, you start at this point. So y equals 5 sine 2 x, and this will be plus pi over 8 because it's a left shift. If we want to do, say, cosine, you'd have to start at the peak. So it would be y equals 5 cosine 2 x minus pi over 8. And again, you don't have to give me both. Just give me one or the other. Most people typically work with sine. Okay? But the cosine answer is also correct.